Hello everybody, welcome to the P9 worksheet. What we're doing here is we're talking about solving systems equations many different ways. All right, so on P7 we learned about substitution, on P8 we learned about elimination. We'll utilize those in this case based on best case scenario. And then I'll remind you of one that we learned in first semester as well. As far as the systems of equations solving goes. So take a look at question number 1. If we look at this problem, it's set up perfectly because we have our x's and our y's and our equal signs and our constant numbers lined up. It's set up perfectly for elimination method. And so what I'm going to do is I'm going to multiply to make my x's go away in this case. To do that, I'm going to make this already a positive 2. I'm going to make this one be a negative 2x. So I'm going to multiply everything in this row by negative 2. When I do that, I get negative 2x. I'll get a positive 2y, and I'll get a positive 2. That's everything in the top row by negative 2. Rewriting the bottom row right underneath it. I'm now ready to add straight down. And so when I do that, my x's are gone, of course. That's what we wanted to do. I end up with 5y, I end up with negative 10, and when I divide by 5, I get negative 2. So my y value is negative 2. Now I can use elimination method, I can use substitution method on the second half of this, whatever I want to do. Well, it's set up pretty well for elimination method if I just make the top row a negative 3y. Let's go with the positive 3y. So I'm going to multiply everything in the top row by 3 this time. All right, 3x minus 3y equals negative 3, everything in the top row by 3. And rewriting the bottom row again. When I add straight down, I end up with 5x's. My y's are gone. I end up with negative 15. So when I divide by 5, I get x is equal to negative 3. And so my answer is negative 3, negative 2. All right, that's using elimination method. Of course, we can always use substitution within that same method. On question number 3, this is set up perfectly for substitution method. What we mean by there is that we have a y equal to or an x equal to, in this case, a y equal to. So I'm going to substitute in place of y, I'm going to put x minus 3. So I'm going to rewrite the bottom row, 6x minus. Now, instead of the y, I'm going to put x minus 3 in parentheses. Equals negative 2 to finish out the row. Now, the thing I got to remember here is that this doesn't have a number in front, but it really does. It's really a 1, in this case a negative 1, that I'm going to distribute through. So I end up with 6x minus x plus 3 equals negative 2. Combining like terms, I end up with 5x plus 3 is equal to negative 2. Minusing the 3 to both sides, 5x equals negative 5. And dividing by the 5, I end up with x equals negative 1. Now, the easiest way with substitution is that means I have a variable all by itself already. I've solved for the x. I'm just going to plug in place of the x and negative 1. So I'm going to go y is equal to, and now substitute negative 1 in place of x. And of course, negative 1 minus 3. You might use a calculator for this just to make sure you're accurate. But it ends up being a negative 4. So we end up with negative 1, negative 4 for our answer. That's question number 3. Moving down to question number 5, you'll notice that I included a graph on this one only because it's set up perfectly for graphing. I have 2 equations, both in slope-intercept form. I might as well go and do the y-intercepts and then the slopes followed by it. So I graphed the top equation. I'm going to end up with, I start at a positive 4, and its slope is a negative 5 over 4. So I'm going to go down 5 to the right 4 to get my second point. Now I need to use a straight edge. When I'm doing systems equations, I have to use a straight edge and be very, very careful. And so what I'm going to do is, this happens, welcome to Albert Pujols here. I got an old baseball card that I like to use for my straight edge on these videos. But there's my first line. On the second line, we have a y-intercept of -2. So I do y-intercept of -2, a slope of 1 over 4. So rides 1 to the right 4, and I have a second point. And I'm now ready to connect those guys. And you'll notice that the two lines, by the way, when I drew my lines, notice I went edge to edge. The arrows are off the graph. What I'm looking for is, where do they cross? That ordered pair is 4, -1. There's my answer, 4, -1. Now, question number 7. Remember, we have a lot of choices. We can go elimination method. We can go with substitution. In this case, substitution seems to be the best thing to do. And that is, we're going to go -2 times 4y plus 5 plus 6y is equal to -10. Distributing through, I end up with -8y minus 10 plus 6y equals -10. The y's make -2y's. When I add 10 to both sides, I'm going to get -2y equals 0. Of course, when I divide by -2, I'm going to get y is equal to 0. Now, when I substitute, x is equal to 4 times 0 plus 5. X is equal to 0 plus 5, which means it's 5. My answer, 5, 0. You do the even side, send me the results, and we'll get you the reassessment if you're doing well. See ya.